Here's an interesting problem. We have a quadrilateral with a circle inscribed in it. 3 of the sides are 7, 9, and 13. What is the 4th side length? We don't know the radius of the circle, we don't know any of the angles. How are we going to figure out the side? Let's draw perpendiculars from the center to all 4 sides. Let's connect the center to one of our vertices. Take a look at the pink and green triangles. One of the sides of each triangle is the radius of the circle. And they're also both right triangles, and they both share the same hypotenuse. Therefore, the triangles are congruent. And that means our 2 tangents from this point have the same length. And in fact, for any point outside the circle, if we draw the 2 tangents, by the exact same logic, they're going to be equal. So the 2 green lines are equal, the 2 pink lines are equal, and the 2 blue lines are equal. Now there's something really neat we can do here. Let's put together our top segment and the bottom segment together. And notice the middle part here is our 3rd side, which has a length of 9. If we remove the middle part, what are we left with? Blue plus orange equals 13 plus 7 minus 9, 11. So the 4th side length is 11. Another fun fact, there's actually a name for this, Hito's theorem. In a quadrilateral with an inscribed circle, the sum of the opposite sides is always equal.